Well, good afternoon. We're looking at problem 6.22 today. So this was one of the homework problems. I have the free body diagram already written up on the board for us and the problem statement. So today's problem statement is to determine the force in members BC, BE, and FE using the method of sections. Method of sections. Let me show what we're doing here. So we are either going to use the left-hand section or the right-hand section. Notice that regardless of what section we use, that there will be a support member. So if you've watched the last two videos, you noticed that I didn't look at the support members because the section we chose didn't contain one. This one will, so we'll need to do our due diligence and go ahead and calculate the values for the reactions at the support for A and at point D. Point A has a roller, point D has a smooth pin connection. We'll use the equilibrium equations to do this. I feel like we've done this like 1,000 times. You guys probably feel the same way. All right, forces in the x direction. We've got negative 2.5 kips. That's an external force at point B. And we have dx, sum of which is 0. Dx is equal to, you guessed it, 2.5 kips. I'll go ahead and fill that in. Looking at the summation of the forces in the y direction, we have two unknowns. So we'll go ahead and come back to that one. I'm going to take the summation of the moments about point A. So if we do that, the external force at point B is a player, at point F is a player, dy is a player, dx is not a player. Notice dx pulls through the line of action of point A, so that distance would be 0. So let's see what we have. We've got 2.5 kips with a perpendicular distance of 4 feet. We've got 2.5 kips, oh, I'm sorry, we've got dy, perpendicular distance of 9 feet. And we have 12.5 kips with a perpendicular distance of 3 feet, whose sum is equal to 0. We are taking the moment about point A. The external force at B will cause a counterclockwise rotation, which is positive. D will also cause a counterclockwise, which is positive. The 12.5 causes a clockwise, which is negative. Performing the indicated arithmetic, solving for dy, we get the dy is 3.06 kips. So 2.5 times 4 plus 9 dy minus 37.5. Combine those terms alike, divide by 9. 3.06 kips. Now we can go pick up summation of forces in the y direction. AY minus 12.5 kips minus plus 3.06 kips equals 0. Negative 12.5 plus 3.06 is equal to negative 9.44. So AY minus 9.44 kips equal to 0. Therefore, AY is equal to 9.44 kips. I'll go ahead and fill that in. So that's our supports that are, that's our reactions that are supports at point A and point D. I'm gonna pause the video right now so I can erase the middle part so we can move on to the always exciting method of sections. Be right back. All right, welcome back. While you were gone, I quickly did a free body diagram for this section. I'm going to use the left-hand section. I actually worked this problem last night using the left and the right hand section and got the same answer for both. So that was always that's reassuring, of course. Let's see that administratively there's a little bit of work we need to do. So force BE, remember BE has a it's diagonal, so it'll have an X and a Y component. We'll do a quick calculation for that. So this is BE. So B, I'm looking at, if you're looking over on the right-hand side now, I'm going to be using this angle here. So the arctan of 4 over 3. Arctan of 4 over 3. Typing it into my handy dandy real quick. Big surprise, 53.13 degrees. So the X component is BE cosine 5313, and the Y component is BE sine 53.13. Oops. So currently I have that B going down, which means that the X component goes to the right and the Y component will go down. So we'll see how that works out. That's my plan of attack anyway. All right, what do we got here? So we've got one unknown in the Y direction. So let's just start there. Summation of the forces in the Y direction, positive 9.44 kips. That's the reaction force at point A. Minus 12.5 kips. That's the external force at Y. And then we have negative BE sine 5313, which is the Y component of member BE. So we've got 9.44 minus 12.5. So that's negative 3.06 minus BE sine 5313 equal to 0. That should be kips. Nice catch. Add 3.06 to both sides. Divide both sides by sine 5313. And we get sine 53.13. We get negative. Where was I? Negative 3.83. Sorry. Negative 3.83 kips. The negative doesn't mean the force is negative, just means the direction that I assumed that B was incorrect. So I'll go over there and correct that real quick. We've been using red for that, so we'll continue that. That is going into the pin, which would be a reaction to the member being in compression. 3.83 kips in compression. All right, let me get out of that color. If we take a look at the moment about point B, that would allow us to grab FE. So let's do that. Moment about point B. So moment about point B, we've got 9.44 kips. Point B is 4 feet. Where's point B at? Moment about point B, 9.44 kips. That's 4 feet away. Last night when I worked it, I did something different. Hold on one second. Let me pause. I think I misspoke. So the distance between the perpendicular distance between point B and point A is 3 feet. So I don't know what I was thinking a minute ago. I lost my mind, temporarily lost it anyway. The 12.5 is in the line of action of point B, so the distance be 0. That's a non-player. We also have FE. And the perpendicular distance between point F and point B is 4 feet. If we're rotating about point B and pushing up at point A, that's counterclockwise and negative. If we're rotating about point B and pulling to the right at F, that'll cause a counterclockwise, which is positive. Taking a look at the arithmetic, 9.44 times 3 is 2832. It'd be negative 28.32 kip feet plus FE times 4 feet. Add 28.32 to both sides, divide by 4, and we get FE is equal to 28.32 kip feet divided by 4 feet. I think it's 708, 7.08 kips. And I got a positive number. It means that I have the correct orientation for our arrow. So the arrow, the reaction at pin F is to pull away, which would be a reaction to the member being in tension. 7.08 kips tension. And hopefully that now will allow us to grab the last of our pieces. So summation of the forces in the X direction. We've got the negative 2.5 kips, that external force up there at point B. We've got BC. We have, so since the X component for B will be negative now, so negative 3.83 cosine 53.13 degrees. And I feel like there's one more, and there is, and that's FE, which we had at plus 708. Equal 0. 3.83 cosine 53.13. That's at 2.3. So negative 2.5 kips plus BC minus 2.3 kips plus 708 kips equals 0, which means that BC is equal to 8. I'll do it out. So negative 2.5 minus 2.3 plus 7.08. Yep, 2.28. So BC is equal to 2.28 kips. And I have it positive, or that's positive, which would be an indication that I have the correct orientation of the reaction. So BC is also in compression. And I think, as I mentioned earlier in the video, I actually worked this out both ways. I used the left-hand side, and then I reworked it using the right-hand side, or the right section, and got the same exact answer. Hope it's helpful. Leave a comment in the comment section. See you in the next problem.